We have always held the belief that the universe is expanding, which has shaped our comprehension of existence and the very nature of spacetime. Yet, what might occur assuming this major conviction were broken? If the universe stopped expanding, what would happen? This is the terrifying discovery made by the James Webb Space Telescope, which has astonished astronomers and scientists. Not only does this discovery challenge our existing understanding, but it also raises the possibility of an ultimate scenario that is analogous to the universe's formation. We have long investigated the profundities of room, going back almost 13.8 billion years, close to the enormous detonation itself. Science fiction and religious visions of the end of the world have always depicted a tragic end for our world. What if the universe's end was identical to its beginning? The universe has stopped expanding, as predicted by renowned scientist Brian Cox and confirmed by the James Webb Space Telescope. The most realistic starting point for imagining the end of the world is this revolutionary discovery. The earliest light in the universe, the light that began its journey before galaxies even existed, is now visible to those who still question the Big Bang. In our understanding of the universe and its history, one thing we can be sure of is that the Big Bang shaped our existence. The astronomical community has generally accepted that our history began with the Big Bang, despite the existence of alternative theories like eternal inflation and the oscillating universe. This event is the foundation of our understanding of the universe's birth. It is more than just a theoretical construct. The Big Bang theory is more than just an explosion, it is a complicated phenomenon that started from a point that was extremely hot and dense. 1/100 of a billionth of a second, or 1034 seconds, after the universe began, this point of expansion reached its maximum. The universe experienced a massive expansion known as inflation during this time period. Space extended quicker than the speed of light, expanding in size by a component of 90 immediately, from subatomic size to the size of a golf ball. Matter as we know it today began to form 1 second after inflation as the universe began to cool. Protons, neutrons, electrons, anti-electrons, photons, and neutrinos, particles inherited from the Big Bang, filled our universe in the first instant. How we might interpret the huge explosion is hypothetical. It was studied by early scientists using mathematical formulas and scientific models. Starting from the principal moon handling, our innovative advances have developed dramatically, permitting us to investigate the chance of life on Mars and then some. Be that as it may, our innovation actually has constraints. The Big Bang cannot be recreated or observed directly. Our most evident evidence is the cosmic microwave background, which permits scientists to observe the Big Bang's echoes. We are unable to observe gravitational waves or the expansion's residual radiation, so this method has some drawbacks. Even though our knowledge is based on theories, it's important to remember that scientific theories can always be improved and even proven wrong. One of astronomy's most enduring beliefs has been that the universe is expanding for decades. A science textbook from the early 1990s will state that the universe is expanding in all directions. However, new interpretations and refinements are constantly being made to our understanding of what this expansion entails. Recent data from the James Webb Space Telescope raise questions about this long-held belief and raise the possibility that the universe has stopped expanding. Prior to considering the ramifications of this finding, understanding our earlier knowledge is significant. Although the Big Bang is frequently referred to as a massive explosion, it was not one in the traditional sense. NASA asserts that space did not exist prior to the universe, so the universe did not expand into space. The enormous detonation is best considered the concurrent development of room wherever in the universe. This nuanced understanding uncovers that our universe has had to deal with a long inestimable period hindered exclusively by the reionization of room. Our universe was completely black prior to this chemical event. After the Big Bang, 400 million years later, clumps of gas transformed into stars and galaxies, bringing the universe out of the cosmic dark ages. This was the "let there be light" moment. An understanding of gravity is essential to the investigation of the universe's expansion. NASA and other reputable scientists believed in the 1990s that gravity would eventually slow down the universe's expansion. They hypothesized that the ever-increasing distances between celestial bodies would be counteracted by the gravitational force that binds galaxies together. It was thought that the expansion would be slowed down by this gravitational force, which has existed since the universe was created. However, everything was altered when the Hubble Space Telescope, HST, was launched in 1998. Utilizing the HST, researchers investigated distant supernovae and discovered evidence that debunked previous hypotheses. The universe is expanding at an ever-increasing rate rather than slowing down. Scientists were forced to rewrite and revise their theories as a result of this monumental discovery. The findings of the HST show that the universe's rate of expansion has been increasing at an ever-increasing rate since its creation, a finding that astonished scientists and cast doubt on their fundamental understanding. Dark energy is a brand new concept that emerged as a result of the discovery of the universe's rapid expansion. Dark energy is a mysterious force that is responsible for the universe's rapid expansion and makes up about 68% of it. Since the late 1990s, this idea has been an important part of our understanding of the universe. The universe is thought to be expanding at an ever-increasing rate as a result of dark energy acting as a counterbalance to gravity by tearing galaxies apart. Regardless of advances in our innovation and information, dull energy stays quite possibly of the best secret in cosmology. Its nature and properties are still largely unknown, despite intense research and discussion. Our understanding of the universe and its future has been profoundly altered by the discovery of dark energy. This suggests that the universe will expand indefinitely, eventually leaving it cold, dark, and empty. New data from the James Webb Space Telescope have challenged our understanding of the universe's expansion with unprecedented precision. As per ongoing perceptions, the universe might have quit extending. This revelation is both alarming and conflicting with our past hypothetical information. For a long time, scientists have held the belief that dark energy is accelerating the universe's expansion. However, brand new data point to the possibility that the expansion has ceased entirely. Our understanding of the universe and its future is profoundly affected by this discovery. A new phase of cosmic evolution may have begun if the universe has stopped expanding. A big crunch, in which all matter collapses into a single point, is one possibility. The universe may begin to contract. There is also the possibility that the universe will remain static, resulting in a big freeze, during which all stars will eventually vanish and temperatures will drop. The rapid expansion of this singularity resulted in the formation of elementary particles and, ultimately, galaxies, stars, and planets. One of the most important pieces of evidence in support of this theory is the cosmic microwave background, which is the faint glow of radiation left over from the Big Bang. Decades of observation and theoretical research have shaped our understanding of the Big Bang and the universe's evolution. This understanding was greatly aided by the discovery of cosmic inflation, the early universe's rapid expansion. The large-scale structure of the universe and the uniformity of the cosmic microwave background are both explained by inflation. However, the James Webb Space Telescope's most recent observations suggest that our understanding of the universe's evolution may require revision. Mechanical advances had a significant impact in our investigation of the universe. Each new instrument provides deeper insights into the universe, from the earliest telescopes to the Hubble Space Telescope and the James Webb Space Telescope. We are now able to observe far-off galaxies, investigate the properties of dark matter and dark energy, and investigate the possibility of life on other planets thanks to these advancements. The James Webb Space Telescope, in particular, represents a significant advancement in our observational capabilities. Its high-level instruments and high accuracy have given new information that challenge our past comprehension of the universe. We have been able to see light that began its journey billions of years ago thanks to the telescope, which has allowed us to see further into space and time. The possibility that the universe has stopped expanding is one of the groundbreaking discoveries that have resulted from these observations. The possibility that the universe has stopped expanding has opened up new research and discovery avenues. In order to take into account the new data, scientists will need to modify their models and theories. The nature of dark energy, the destiny of the universe, and the fundamental physics laws are fundamentally challenged by this finding. The mechanisms underlying this phenomenon are likely to be the focus of future research. Dark energy's properties and its role in the universe's expansion will need to be investigated by researchers. They will likewise have to investigate elective hypotheses of enormous development, like the chance of a cyclic universe or a multiverse. The revelation that the universe might have quit growing has significant ramifications for humankind. It tests our comprehension of the cosmos and our place in it. We are forced to confront the possibility that our universe may have a limited lifespan as a result of this discovery, which raises the question of what will happen to all matter and energy in the end. Additionally, this new understanding emphasizes the significance of ongoing scientific investigation and discovery. Our insight into the universe is continually developing, and new revelations can on a very basic level change how we might interpret presence. We are reminded of the significance of curiosity, exploration, and the pursuit of knowledge by the discoveries made by the James Webb Space Telescope. The James Webb Space Telescope's groundbreaking discovery that the universe may have stopped expanding challenges our understanding of the universe. Our understanding of the universe's creation, development, and ultimate fate is profoundly affected by this discovery. It opens up new research areas because it forces scientists to rethink their models and theories. What's more, revelation. In the end, it demonstrates how crucial it is for our comprehension of the universe to continue investigating and learning new things.